We now have Sunny's session. Sunny has been a long-term backer of APSIG and the various other SIGs in the region. Sunny and of course APNIC, where he works. Sunny will be introducing the core internet technologies to us so that all of us are on the same page as far as the technical aspects are concerned. Please use the opportunity to raise any questions that you may have, whether you are technical or non-technical. So over to you, Sunny.
Thank you, Satish, and hope everyone can hear me and see my slides.
Yeah, we can see you and hear you.
Thank you. Thanks so much for inviting APNIC to be part of this session, Day 0 session. And it's really, personally, I'm feeling very happy to see so many familiar faces and so many names that I can recognize, so it's good to be back here with APSIG, though it's a virtual event, but it's very happy to be back with APSIG. Usually if this is a physical event, I do a role play. It's a game. It's IP-Go game, and I actually play the game with you all. But since it's a virtual one, I do my best, and it's also past my bedtime. But stay with me. Before I start, let's have a protocol for this session. As Satish said, if you have any questions, feel free to ask me, but please raise your hand. If I see someone raising your hand, then I'll let that person speak or ask me a question or make a comment or provide their explanations. Before you speak, say your name and ask your question or make a comment. And a big thanks to my colleagues at Asia for helping with this session, as well as with the APSIG. They're actually staying back and doing a great job. So thanks so much. So I'll dive into my presentation. Now I have slides, but I have inbuilt interactivity in the slides as well, and we will see how it works. So this is about core internet technologies, and there's many, okay? But I only have, I think, about 30 to 40 minutes, so I'm not be able to cover everything in this session. But the aim of this session is to set the scene for you, for your engagement for the next 3 days of APSIG, because the speakers in those sessions may be referring or speaking about technologies or referring to how internet works, So I hope this session will help you understand the basic concepts of internet and the internet governance around it, for you to then engage effectively in the other sessions, which will be more in-depth. As I said, I'm seeing so many familiar faces here. So either you have attended other events like INSIG, Youth IGF, or APR-IGF, other internet governance, or APNIC, or ICANN and ISOC. So some content of my presentation for you will be repetitive. So what I ask is, I'm not the presenter here. We are all the presenters, okay? I'll drive the slides and I'll go through it. But if you have anything that you have learned from other events that you want to share with other colleagues here in this session, please do so, but keep it very concise, to the point. Let's not waste time, so everyone get an opportunity to speak and to share. Okay, so let's share what we learned. I'm also here to learn from you guys as well. So let's make it a collaborative one, and then see how it goes. Okay, so let me get this one. Just an overview. I'm going to touch base on history of internet, how internet works, and some of the core technologies. And I have an activity towards the end, but that depends on how I'm going with my presentation, as well as with the interactivity with you guys. If I have any time left, we play that activity towards the end. The figure the image that you're seeing on this slide is n plus n. The machines understand numbers and humans understands names. So that's n and n in ICANN. How many of you know what ICANN stands for? Raise your hand and speak out, please. say your name and speak out. I just need one person. Just raise hand and say what ICANN stands for. Lakshmi, please go ahead. I'll just take from Lakshmi. Lakshmi, can you speak? Or do you need rights to, someone can give a microphone? Yep.
Internet
Okay.
community assigned names and numbers.
Thank you. Thanks so much. I just want to see, how this interaction works. So, okay, thank you so much. And thanks, Kausar, maybe next time. So let's have some interactivity with this presentation. So go to vvox.app, and when you go to that website, it will ask you for a number. You enter that number, and when you enter that number, you should see APSIG2020 welcome. Lakshmi, you can, you still want to say something, or is that your whole hand raised?
I said Internet Corporation assigned names and numbers for ICANN stand.
I got it. Thanks, Lakshmi. Okay, I hope everyone's okay with vvox.app, and you have entered the number. It's very straightforward, and I just checked my phone, it's working. So if it's not working for you, please raise your hand. Okay, I'm going ahead. It's working here. All right. Introduction to core internet technology, history of internet. The first activity.
Sorry, can we have the previous slide once again? The number, I think some people have not got it. Just for 10 seconds.
No, the number is on all the slides, Satish. You can see the number on this slide as well, right on the top.
Right, thanks.
Sorry if you are posting anything in the chat. I got very limited real estate on my screen here. So please, raise your hand and speak out. But the number to join vvox.app is on almost all the activity slides that you can see. And you can take this question, when was the internet invented? I will start now, and you will have 30 seconds. So it's opening for responses. Don't type it in the chat, please. You need to be joining the vvox.app and input that ID number and then take the question there, not in the Zoom chat. Okay, I'm closing that, and the result should appear here. Well, that's great, those who have answered right, 72% of them, it's in 1960s, not in 1970s, but 1970s, I can take that answer as well. But definitely not 1940s, not 1940s, but 1970s I can take, but it's in 1960s. Okay, so let's do this. I hope you're enjoying the activity. So it's all started with ARPANET. It was a research project with the Defense Network in United States. And the first internet message between any two computers was sent on 29th October 1969. So that was internet was invented in 1960s. There was a lot of research going on, and then there were two computers that connected together and exchange message, and the message was login, but it failed after 2 characters hello. And the first internet backbone, and now our backbone, today's backbone is much larger, huge, but the first internet backbone was between 4 computers, and you can see the image on the slide as well. And these 4 computers are placed at the universities in USA, and they were connected together. What happened on that early internet? What did they do? So basically, they telneted into each machine, and then they did file transfer. Slowly, then they started exchanging messages, email, and then Usenet, the news groups came, and Usenets are like current social media, like Facebooks and everything. But in those days, they used to have Usenets or bulletin boards, and that's how they to interact with others on the internet. So that's how it started. And you can see in the image, some of the Usenet groups in those days, computers for comp, humanities, news, and some of those, talk. Yeah, there's many. If you can Google, you'll find so many Usenet groups, and these Usenet groups are even used even currently as well. A lot of techies, they actually use these Usenet groups. Next one, the birth of TCP/IP. So the first protocols developed. We are now talking about core internet technologies, right? So this is one of the core internet technologies. The first protocol was developed in 1822, and it was network control protocol. So the answer 1970, 70s, I said, I can take it because it was still the development of internet, 60s and 70s as well. So the network control protocol was the first protocol designed to interconnect computers with each other. And you can see in the image on the slide, 15 sites were interconnected by end of 1972. Can you imagine how many sites are connected now? Over thousands of sites are interconnected now. But in those days, they started with 15 sites. And then Windsurf and Bob Kahn, we refer them as fathers of the internet. They designed TCP/IP in 1981, the transmission control protocol, internet protocol, okay? Not intellectual property, it's internet protocol. And this one got standardized in 1982. When I say standardized in 1982, that means they stopped using the NCP and they moved from NCP to TCP/IP protocol to interconnect all the computers. So the first TCP/IP packet was sent on 1st January 1983 because they were transferring from NCP to TCP. It took time and testings, everything, but they successfully sent that first packet over TCP/IP on 1st January 1883. Now, when I say packet, you might think a packet means, something, an envelope and, something in it. And the messages that carry on the internet, we call them packets. They go in small bits and pieces, and then they're joined at the receiver's end. So that's how internet works, and this is a image of how everything is connected to the internet. The internet is now a big cloud in the middle, and we have devices connecting to it. So these days, you can have your mobile phone connecting, and if you're flying from one place to the other, you have internet on the flights as well. You can have internet in your car, while you're driving. You can still connect to others and communicate with others as well. So, and that big cloud that you see in internet is comprised of many, many, many networks. Okay, many, many networks interconnected with each other. So the circles, the blue circles you see in the middle is the internet backbone. These are the things that connect to each other, and then all the devices, everything connects to them to exchange packets between each other. Okay, we also have mobile network or wireless network. We have wired network. Okay, we are connected with submarine cables. Each country is connected with submarine cables, and also we have Wi-Fi. We also have satellite connections still, your GPS in the car or GPS that you use, works on satellite, right? So we connect to satellites as well. The primary reason that we have still satellite connectivity is because, we never know what happens with the cable internet connection. If cable internet connection is broken, then we have a backup connection. Mute whoever that is, mute your microphone, please. Thank you. So yeah, that's how the backup connection, all the internet is still runs on backup connection through satellite as well. And the satellites are a bit advanced than what we used to have before. The satellites can transfer the data much faster these days, but not as fast as the cables, the fiber optic cables. So as I move along from slide to slide, I'm introducing different things in that image. So you saw a big bubble in the middle, first one, and the second one you saw the internet backbone. All the those big circles connecting to each other. Now you see some numbers on these slides, right? On these images, right? So can anyone tell me again? Raise your hand. What are the numbers in the blue color? Now, I know some of you have attended APNIC conferences, APRIGF. I can recognize the names, when I'm looking at the participants list. You have been through this before. So the first person was Subedri Budari. Please, what is that blue number is?
Yes, yes, these are the IP addresses. This is Suhaib Bukhari actually from Pakistan.
Sorry,
Thank
you
you.
have to understand my question. I'm asking you the blue number. The numbers in
Yes,
blue.
these are the IP addresses, I believe.
Okay, what version of IP address is that?
This looks like IPv6.
Now the blue one is IPv4. The
The blue one
green
is
one is
IPv4, yes.
yes, the green color one is
Yes.
IPv6. IPv6 is hexadecimal and IPv4 is not hexadecimal. So now I'll go to this. Okay, please put your hand down. Thank you so much. I'll go to the next person, Afzal Raja. What is the number in the red color?
Abdullah Afzal here. The red color, I think it's router's address or something, ISP's address, maybe something
Well,
related to
the answer
ISP.
is just before that number. It's already in the number, the answer. You just have to say what it is.
I don't have an idea.
Okay, thank you. Next one, Lakshmi. Do you know what that number is?
Autonomous system.
Exactly, correct. Very good. Autonomous system number. Okay. And those numbers are used by the routers. Now, those blue ones, the blue circles are called routers. The routers use autonomous system number. Autonomous system number is, if you go back to your traditional way of communicating with people, like in a postcard, you write your address of the person that you're sending your postcard to. And towards the end of that address, you write a PIN code or a postcode, right? And that is exactly what this is. This is like a pin code, postcode, where that information have to go, and then from there, where it should go out. So the AS number is like a postcode in a traditional snail mail, right? And the IP addresses, the IP number V4 and V6 are the numbers that we can call it address. When you write a postcard, it's like an address. Okay. Thank you so much, and you can put your hand down. So next one, let's go into core internet technologies. Which is the most used internet protocol? Again, it's an activity for you. Go to vvox.app, enter that ID number if you haven't, or if you already entered and you're there, answer this question. I'll start it now. Which is the most used internet protocol? Okay, you can name one or you can name two, it's up to you. So I'll start now. I'll give 30 seconds. There is no right and wrong answer. Just type whatever you think. Okay, I'm not picking a winner here. I just want to see, how much you understand and how much you know already. Lakshmi, please mute your microphone. Thanks so much. Okay, I'll stop. And let's see what's coming up on the screen. The TCP IP I already covered. That's very interesting to see that it came up, but it is a protocol. Yes, I asked for a protocol. It is a protocol, IPv4. HTTP is a protocol. That's what I was looking at, how much you understand. Telnet is a protocol. FTP is a protocol. And I hope whoever typed that know what that means. file transfer protocol to exchange files between the servers or computers. HTTP protocol is again is we use for the web, but HTTP is not the current protocol that we use to access websites. Does anyone know what we use now? I think there are a lot of security experts in this participation. What protocol do we use? Raise your hand and just go for it. Just say it. Abdullah?
HTTPS.
That's very good. And I don't see it here, no one put it down, but HTTPS is the one we currently use. And we should always, whenever you access a website, you should always check whether it's HTTPS or not. If it's not HTTPS, I suggest don't visit that website, because you never know what malicious content is on that website that may inject into your laptop or your device. Especially when you're doing transactions on the internet, like bank, financial transactions or emailing or, connecting with others. Always make sure it's digitally certified website and it's HTTPS. Okay, thanks so much for taking this activity. Let's move on. So the key internet technologies I'm going to talk about is internet protocol, which I already touched base, routing and domain names, okay? But as the previous exercise explained us, there's a lot more than what I'm going to present in this one. This one I already went through, designed by Windsurf and Bob Kahn in 1981, is the internet protocol. This is a great invention, I would say. All the communication that is happening on the internet now, and I believe in future we'll be using the same protocol, TCP/IP protocol, over the internet IP addresses. The communications happens, and it's a well-known set of rules and standards. Everyone is using it across the world. All the devices on the internet are identified by these numbers, either IPv4 or IPv6 or both IPv4 and IPv6. It's just like our mobile phone. When you buy a mobile phone, you need to connect to a mobile operator. And when you connect to a mobile operator, they give you a mobile number. And that mobile number is unique, right? It's unique to you only, okay? What happens if you and I have the same mobile number and someone calls that mobile number? We both receive, or no one receives the call because there's a jam, on that number, right? So these numbers have to be unique. Then only we can exchange packets between each other, okay? There won't be any collision if we have, if the numbers are not unique. There will be a lot of collision. And those pictures, the first one is Windsurf up there, and then the second one is Bob Kahn. You may, if you attend IGFs, if you're a fellow and you're attending IGF or ICANN, you may bump into Windsurf, if you're lucky, and you please go and shake his hand and thank him, for inventing internet for us. Okay, internet protocol, the data is sent over the internet in discrete packets. That means small pieces of information that the email you're sending or whatever you're sending to the other person gets chopped into small ones, and they send from a source. That means if you're writing to someone, you are the source. And if you're writing to me, I'm the destination. So from source to destination, okay? And every source and destination in the internet must have an IP address. So you may not see the IP address. You may not know my IP address. You just say Sunny, and you write a message to me, Sunny. But my device have an IP address, okay? When you send it, it gets translated from the name to numbers, and it comes to my device, and then I read your message, okay? We'll go into that one later. IPv4 version and IPv6, I won't go too much into detail, I'm watching my time. But IPv4 version is a dotted decimal notation, and you can see, it's 8 bits, okay? And we have about 4.3 billion possible addresses. The reason I put it in red color is because we ran out of those numbers. And that's why we are moving now to IPv6 version, which we have abundance, 340 undecillion possible addresses that we can assign each and every unique IPv6 number to a device, no matter how many devices you carry. These days, on average, we have at least 3 devices with us: a laptop, a mobile phone, and a smartwatch or a smart device, that you may have. So at least on average 3, and every device can. And these IPv6 numbers are hexadecimal. That's why we have many of them. We're using alphabets and numbers to mix and match and to make that large number. It's a 128 bits number. The next one is the most important, is when I refer to internet numbers, that's what APNIC deals with, is internet numbers are only 3: IPv4, IPv6, and autonomous system number. Now, autonomous system number are used by the routers, by our ISPs that we connect to. They use autonomous system number because they're like a post office. They receive information and then they send it to us, right? So they need a postcode, to know, who is who on the internet. So, and again, the 2-byte AS numbers are running out, because they're only 65,536 numbers. They're almost gone. And then they introduce the 4-byte numbers, which is a 32-bit number, and we have many numbers of those ones. Now, though these numbers are primarily only used by the ISPs, the ISPs are growing everywhere in every economy you see. If you're from India, you probably had only VSNL, the incumbent. Now you see so many Jio, Tata's, Vodafone, Hutchison, everyone. And you go to any economy, Singapore, Hong Kong, anywhere, there's multiple ISPs, right? And they're growing. Okay, they're large ISPs, there's second-tier ISPs, they're third-tier ISPs. Okay, the smaller ones. Okay, and they all need these autonomous system numbers. Now, where do these addresses come from? When I say addresses, the internet numbers, okay, the numbers come from IETF, the standards. This is the place where the scientists, the researchers, everyone, the engineers, they discuss the protocol, the standards, and then they define, and then they agree on them. And these numbers are passed on to IANA. IANA is a branch department in ICANN. And it's written in the slide, so I'm not going to expand that. You can read it. And then IANA distribute these IP numbers to RARs, regional internet registries, and the regional internet registries assigns to the LIR, the local internet registries, or the internet service providers in an economy, and they give it to us end users. Now, you might be thinking, but Sunny, I never got an IP address from my ISP when I connected. No, you won't see them, okay? But they are in your home Wi-Fi router. They assign to your router in your home Wi-Fi. And then the home Wi-Fi router assigns to your laptop or your mobile phone when you connect. Regardless whether you're connecting through cable, or you're connecting wirelessly, or you're connecting through mobile data. Okay, if you're connecting to your mobile operator using mobile data, you still have an IP address in your mobile phone, as well as a mobile number. Okay, the mobile number is used for your voice calls, SMS, and the IP address in your device is used to connect to the internet. When you make WhatsApp calls and all those, they go on the IP address. All right. Question, is it question, Abdullah? Sorry, I saw your hand raised, but I just want to stop what I'm explaining. Do you have any comment or question, Abdullah? No? Okay, thank you. Oh, sorry. So when I talk about internet registries, there are 5 internet registries in the whole world, and they're divided as per the regions. So the first one up there, in yellow color, is RIPE NCC for the entire Europe. Then we have orange, AFRINIC is for the African continent, AREN for the North American, and LACNIC for the South American continent, and APNIC, the blue color in the middle, is where I work for, and we all belong to APNIC region here, if you are from Asia Pacific. But I know there's some participants from other regions as well. So these are the bodies. These are the only 5 bodies, the registries that distribute IP numbers. Okay, don't get confused. Not names, domain names, IP numbers, IPv4, IPv6 AS numbers in autonomous system. These are the bodies that distribute to their own region, to the ISPs. Now let's go into the routing. The second one is routing, core internet technologies. What is routing? Let's go back to the traditional snail mail. Okay, you write a postcard and you put it in the mailbox. okay, the red color one or green color one, whatever one. You put it in there, and the postman comes, takes it, and takes it to the post office. Okay. When it goes to the post office, there's a lot of people there in the post office. They sort the letters. They see which one goes which side, which one is local, which one is international. They sort them out, and then they distribute them, and then they go from there onward. So it's the same in internet. It's the same. The routing is refers to the process of taking a packet from device and sending it to another device. It's transversing between two devices. And this is usually performed by routers. Those blue color ones in the image that I showed, they're symbols of routers, with the crisscross. And routing enables user to access content stored on remote devices. So these days we access a lot of content. We go to Facebook, we go to Google, we go to YouTube. Whatever content you are accessing, they are going through these routers from your ISP to the other ISP to wherever the Facebook is, and coming back to you. Okay. So that's what the packet travels between several internet autonomous systems before it reaches its destination. So when you send something, an email, it goes on many, many, many wires, cables, and internet wirelessly, or through the underground sea cables, and through many routers, and it reaches the other person who you're sending it to. So this is a good example of routing. As you can see, some devices are connected wirelessly, and some are connected, to the wired internet. Some are connected to the satellite, especially when you're on a flight and you're accessing internet, it's connecting to the satellite, and then bounces the traffic to the a base station, it could be a tower on somewhere, and then that goes through that traffic still goes through the router, okay, and then goes to the destination wherever it is. All right. Routing packets does have a protocol as well. How do routers talk to each other? There's a protocol, it's called Broader Gateway Protocol, or short BGP. If you're a technical person, you know what BGP stands for. BGP is nothing but a language, it's a standard, it's a language. Now I'm speaking to you all in English, okay? So this is my BGP, I'm speaking to you. If I switch to my mother tongue, which is the Indian language, maybe one or two from that part of India may be able to understand me, but others won't be able to understand, right? So we need to have a standardized language, a standard for this router to talk to each other, and that's BGP. But if you're looking at the graph, the BGP graph, where the routers are connected, then you might ask, what is eBGP, what is iBGP? Well, BGP is a standard protocol. Within one autonomous system, like if you take Reliance Jio or Syntel, or Vodafone, within themselves, they use BGP, but it's called interior BGP internally, and then exterior BGP when they talk to Vodafone to Jio, that's exterior BGP, okay. That's too much of technical. Other important technologies we have, internet exchange points, where the content stays local. That means, when you want to send for example, an email from Mumbai to Delhi, it doesn't have to go to Hong Kong, it doesn't have to go to Singapore, right? It's only within India. So it just goes to the local internet exchange, and from Delhi to local internet exchange, and then it goes from there to Delhi, why we have internet exchange points? To save international bandwidth costs, because if the email goes from Mumbai to Delhi via USA, via London, via Europe, and comes to Delhi, that's a very bandwidth cost. ISP have to pay the cost to every single one in that leg. Okay, so to minimize the cost, and also to lower the internet cost for users. If the ISPs are saving money, then they pass that cost to the users as well. So the cost of internet for you users will come down as well. And also to keep the local traffic local, and latency means the time it takes from from source to destination, how long it takes, that's called latency. That can be minimized as well, so it doesn't have to go through the international circuit and come back, which is a long trip. Whereas within India or within Hong Kong, from one city to other city, you can reduce the latency. The other one is Resource Public Key Infrastructure, RPKI. This is to secure the internet's routing infrastructure. So those routers that you saw, those circles, when they communicate with each other, they need to be secured. So no one can, inject or interfere with the communication between those routers, right? So it's the way they do it is they sign route origin authorization or ROA. This is signed by APNIC or any registry. Okay, when registry assigns IP address to ISP, we say, okay, this ISP is the custodian of these numbers. Okay, no one else in the world, and that ISP have to sign cryptographically sign with us with APNIC to say that they are the custodians of those resources, and everyone on the internet that recognizes them. Okay, when they see those numbers, they say, okay, this number belongs to Geo. Okay, but if they see someone else is spoofing that number in the middle, spoofing other people, then they can recognize it. Okay, this is the bad guy, this is spoofing this IP address that belongs to Geo or that belongs to Hong Kong Telecom, or Syntel. They can identify it immediately. Now coming to domain. Could someone mute your mic? Now, domain names, before I go into domain names, why do we need domain names? Okay. When internet is working on internet numbers, why do we need domain names? Just remember the first slide I showed you, human and a machine with N and N, okay? What did I say? The machines understand numbers, not names, and the humans understand names, okay? We converse in names and the machines converse in numbers. So that's why we need domains. Now, what are domain names? It's nothing but a white pages, yellow pages that we all know. We used it and we also still use it. If you open your mobile phone, your contacts, what do you see? You see the name of the person and the number, telephone number, right? That's the domain names, right? That's the DNS. The DNS is basically it's a very big thick book that every ISP have it in their server, in the domain name server. There's a log of every entry that they carry within their network. The machine name, okay? So my laptop is called Sunny's laptop, but Sunny's laptop, can you send a message to Sunny's laptop? No, you can't, okay? Without having a number that I assign to my laptop, you cannot send a message to me, okay? So this is translated over the internet. Now I'll show you graphically how it's done. So we follow the sequence here from 1 to 9, right? Okay. 1 is the end user, you and me. We are end users and we have a device and we want to reach www.example.com here. So the www.example.com goes to the DNS resolver. DNS resolver is a DNS system, a server within our home or within our ISP, okay? Every ISP runs a DNS server. And it goes to the DNS server of the ISP. Do you think the DNS server of the ISP knows where the www.example.com is? May or may not, okay? May or may not, because not the ISP's DNS server doesn't store all the domain names in this world. It doesn't, okay? It only stores whatever was queried through that server. So if someone before me, someone else went to the same website, www.example.com, then there will be a copy of it stored on that server, and then it can fetch from there, okay? But if no one visited that from this ISP, from this server, then it has to go out and find out where it is. So the third one, the number 3 here is, it goes to a DNS root name server. Now we have many DNS root servers everywhere in the world. They are the master root servers, okay? It goes and asks the DNS root server, where is www.example.com, and the DNS root name server tells that, I don't know where is www.example, but I know where is .com, because I'm a parent for .com. As a master, I'm the parent for .com, so I know my child .com, and then sends that IP address. Along with that response, it goes the IP address of .com name server. And the fourth one, it goes to .com name servers and asks, where is www.example? Now, who is the child of .com here? If .com is the parent, who is the child? Example is the child of .com parent, okay? So the .com says, I know where is example, but I don't know where is www, okay? I'll tell you where example is, and it will attach the IP number of that example.com and sends to the user. And then it goes back to the where that IP address of that example.com, and then the example.com says, yep, this is my server, www is my child. I know where it is. It's my web server, and it gives the IP address of that to the end user, and the end user reaches the web server, and then whatever content that end user is accessing through that web server. In this case, I got Mona Lisa image there, I'm looking for, then that gets sent to the end user. So what happens in this entire scenario? What happens is we human beings are typing a name into the device, into the computer, and the computer is taking that and attaching its IP address and sending it back. Okay. So I don't know where it is, I know the IP address of this, go here. So every part of that, there is a DNS system that's translating name to number, name to number, name to number, and telling the user, okay, it's here, it's here, it's here. And this happens very quickly. You won't even notice that, okay? The reason it happens very quickly is because the DNS is widespread in the world now. There's many root servers everywhere. Almost every country have a root server, 1 or 2 or 3 or 4 root servers, in the country. So it travels very quickly. There's a minimum latency, travels very quickly, the packets, and then gets you the answer, okay? But this also depends on how good your internet connection itself is. If your internet connection is very slow, then the response rate will be slow because of your internet connection, not because of the resolution that DNS is happening, but because of your internet connection. Okay, how I'm going with the time. My time is 10 past 11 here. Satish or anyone, do I still have some more time?
I think you'll have to close in 5 minutes or so.
Okay, if I have to close in 5 minutes, sorry, I can't go to that activity, but quickly, TCP/IP transport data. Okay, it transports data. HTTPS, you access websites, with that. RTP, real-time protocol, is a streaming, you access Netflix, that's the protocol. I'm just putting some other protocols here that you may want to know. Now, I'll stop here, but I'm happy to take questions. This activity is a very fun activity, but I don't have time. You have to imagine what those images are, and you have to relate those images to the internet and put it onto that. Can we have just one activity? Just one, this one, okay? I won't go too many. I got few others there, but let's do one activity and then I take questions. So go to vworks.app and put in that ID number if you haven't done it. Now, I have referred in my presentation, I took examples of traditional snail mail, and I explained, what this is, and how we do it on internet. So we are looking at a postcard and an inland letter, and that's very typical to India, the inland letter. In real internet life, so that's traditional snail mail, right? We write on a postcard or inland letter and we send it to our friends or families. But when you come to the internet, what is the similarity of here, that, or what do you think that is on the internet? How do we communicate on the internet? I'll start it and I'll give you 30 seconds. Again, there's no right and wrong answer, just whatever comes to your mind, just put it in. It's an activity. I want you to engage with me here, then actually giving me a right answer, okay? You got 10 seconds. I'll open my chat box after I finish. Okay, that should stop and the result should come. Email, perfect. Very good. Whoever whoever wrote that email, that's, yeah, email, in olden days, and even now, we still use them. It's not that, we don't use them, postcards and in letters, but yes, on the internet, it's email, that's good. So I'm very happy that, whatever I'm teaching you or explaining you, you are able to understand. Now I'll stop my presentation here and I'll open my chat if there's any questions, or I actually appreciate if you just come to the microphone and make a comment or question, then put it in the chat. So there are so many experts here, and I can see their faces in the participation list. So I'm not the one here teaching you guys. I'm learning from you. So anyone can come up and ask, let's allocate about 5 minutes for Q&A. So if there's any experts in this participant list, and we are all panelists, okay, jump in, answer that question. I like you to answer that question if someone got a question, then me answering to it, because you attended so many of these conferences already, some of you, and I can pick the names here who attended what conferences. Okay, any questions? Lakshmi, go ahead, please.
As per your explanation, once I put any website in the address bar, it first goes to the DNS.
Yes.
Then DNS forwarded to the root server. But the root servers are not now consider it is the IPX. I mean the local internet exchange.
Yeah.
So let's suppose .com, it will be hosted in Nepal, but the root server is not in Nepal. It is somewhere else. Then how work is the local IP?
Let me pause you there. Great question. And you actually touched on two things that there, I'm very quite happy that you touched on two things there. You touched, first one you touched is Internet Exchange. Yes. The root servers actually are mostly located in Internet Exchange. Why Internet Exchange? Because every ISP comes and connects at that Internet Exchange, and everyone can share the resources within that Internet Exchange. That's very good. In Nepal, you do have internet, you do have root servers in Nepal. As far as I know, I think there's about 3 root servers located in Nepal. One is with Nepal Telecom, one is with Internet Exchange of Nepal, and one probably somewhere else with a big ISP. But there are root servers in Nepal. Next question.
Okay, thank you.
And feel free to turn your video on if you want to, but if you have low bandwidth, that's fine. I can understand. Yusuf, please.
Yes, good evening. At least here is evening. So this is
Could you
Yusuf
speak loud,
Fazia.
bit louder?
Yeah, this is Yusuf Fazia from Yemen. And I'd like to ask, the question is, we are looking for the content instead of looking to the address of the content. So that's the concept of content-centric networking. So my question is, will the structure and the paradigm of the internet change to CCN soon or not? What do you think?
CCN, did you say CCN?
Yeah, content-centric networking. Or they call it ICN, information-centric networking. So we look to the content instead of the address. I need your thought of whether the paradigm of the internet is going to change soon or not, because this is a hot research. Some people are doing it these days.
Yes, I was actually going to refer to that one, but thanks. So over the time, if you see what's happening on the internet, and there's many experts in this session, please jump in if I say it wrong or you want to add on to something what I'm saying. The internet is shifting. You're very right. The internet is shifting. We used to have client server technology. We used to have mainframes, and every dumb terminal is going to go and connect and to access. But the dumb terminals are becoming smarter terminals. The devices that we are using are much smarter than those dumb terminals. And also, if you look at the content that we are using, the content is actually coming closer to the users. We are not going all the way to fetch the content anymore. If you look at Google, if you look at Facebook or Akamai, they are putting their content caches. They're called cache. They're replicas. They're putting them where the users are, so the users can actually access the content within their proximity, then going all the way to US and bringing it from there. So in future, what happens in future, I really don't know, but the content is coming close to you. So we're going to have all these economies, or even states or cities in each and every economy will become very big content hubs within close to us. but I'll stop there. And if anyone got a better answer than me or you want to chip in, please go ahead. Vivek, do you want to add? Vivek Rana?
No, I just have a question for you.
All right. If that answers your question, Yusuf, otherwise I'm happy to take your question offline if I didn't answer it that well.
No, that will
My
do.
email
That
ID
will
is
do. You did a
sunny at
great job. Thank you
apnic.net.
very much.
Thanks, Yusuf. Vivek, yes. Well, Vivek, I
My
have to
que-
learn from you. You are the expert, you know.
No, I'm not an expert. I just have a quick
I
question.
can see your face there. You know, you're the cyber guy, you know.
I just wanted to ask a quick question,
Sure.
especially looking at the way that the cloud technology is changing ways on DNS.
Yeah.
How they have been able to design the entire organization network around the DNS, and how powerful the new DNS services are coming up, especially with the Route 53 with Amazon.
Yep.
And content delivery network. Again, looking at it from a very business perspective, because they have over three of them in India. They have now one going on in Hyderabad. Nepal doesn't even have one. So it's sort of creating a more difficult scenarios for people around. And what is your take on this?
I'm not. I can't speak for Amazon. You know what their business strategy is, but
Sunny,
that's a good question. That's a good question.
Sunny, this will be your last question.
Okay.
I'm sorry, we can.
Yeah, I will start. Just let me answer, and thank you so much for your reminder. Yes, this will be last question. Vivek, to come to your point, I can't speak for Amazon, but what their business strategy is. But usually and let's not say Amazon, everyone, whoever is providing content to us, Facebook or Google or anyone, they go to the places where there's a large user base. But saying that, that doesn't mean that they won't come to Nepal. They will come to Nepal, and maybe it's just the time, but they will come and put those servers in Nepal as well. That's what I've been noticing, seeing, what's happening out there. They expand into larger markets first, and then slowly to the mid-term markets, and then the smaller markets. So it's just a matter of time, when they come to Nepal. And thank you so much for being a great participating in this session and giving me opportunity and making it interactive. I really appreciate everyone for staying with me and listening to me, and to the APSIG guys and .Asia, sorry, keeping you busy and keeping you up late, but thank you so much, everyone.
Thank you, Mr. Sunny, for a wonderful talk on the core internet technologies, covering IP addresses, routers, domain names, and how everything works A to Z. That's the basic technologies which need to be understood first for the participants. Then over and above comes the other institutions and other kind of things which is there in the internet governance. Thank you once again, Sunny, for your elaborate talk. So we will end here. Thank you very much.
Thank you.
Thank you, everyone. If you don't have anyone of you are having issue with the sign in or with login to your Zoom account or to access the session, please drop me an email, or you can send an email to Shredeep and we will look into it. We will try to resolve the issue. Thank you, everyone. Goodbye.
Mubashir, just a question for the next 3 days. Will you be sending the link to the speakers?
This is the same link.
This is the same link for the next 3 days as well?
Yeah.
Yeah, okay. But will someone be writing to the speakers, all the speakers with the link?
Yeah, sure. Dr. Govind.
Yeah, I will be writing to all the speakers.
Okay, thanks, Dr. Govind.
Thank you.
Thank you. And bye, everyone. See you on 26th, I believe.
Yeah. Thank you, everyone. Bye.
We'll see everybody on 26th. Thanks and bye.